During the war, the Luftwaffe had some of the best planes and technology that were available at the time. Even though a lot of money and time were spent and a lot of progress was made on piston engine aircraft, people were also interested in rocket and jet propulsion, which were also being developed at the time. As an alternative to planes with piston engines, the Germans started making jet and rocket engines. These allowed them to build and use more advanced planes. These were used in small numbers and much too late for them to make a big difference in the war. Not as many people know this, but they were also interested in making ramjet engines. Ramjets were basically jet engines that had been changed and given a special front nozzle. Without an axial or centrifugal compressor, their job was to help compress air that would be mixed with fuel to make thrust. In theory, this is much easier to build than a regular jet engine, but it can't work during takeoff. So there was a need for a backup power plant. It's important to note, though, that this technology wasn't new. In fact, it had been around since 1913, when a French engineer named René Laurent patented a similar engine. At that time, there weren't enough of the right materials to build a fully functional prototype, and it would be decades before a real ramjet could be finished. During the 1930s, most of this kind of engine work was done in Germany by Helmuth Walter. Even though his first work looked good, he eventually gave up on it and started to work on a rocket engine instead. The German Research Center for Gliding, Deutsche Forschungsinstitut für Segelflug, or DFS, built and tested the first working model in 1942. The engine was put on a Dornier Do-17 and then a Dornier Do-217 to test the first working prototype. As a company that is always interested in new technology, Wulf was interested in the development of ramjets in 1941. 2 years later, Wulf opened a new research station in Bad Eilsen to try to improve ramjet engines that were already in use. Otto Ernst Pabst was in charge of the project. The first work looked good because the ramjets could be made for a lot less money than jet engines and would give the planes a good overall performance. Because of this, Wulf started making designs for fighter planes that would have this engine. The Strahlrohrjäger and the Trebfluegel were two of these ideas. The Strahlrohr was made in a more normal way, although using the word conventional in this project has a loose meaning at best. But when it came to the Trebfluegel, all known and traditional theories about how to make an airplane were basically thrown out the window. It was meant to take off vertically and be powered by a backup engine at first. When it got high enough, the 3 ramjets at the tips of the 3 wings would fire up and turn the whole set of wings. It was hoped that the Trebfluegel would be easy to make in large numbers if it used cheap materials and low-quality fuel. The design was especially strange. It didn't have wings. Instead, it had a rotor propeller assembly about a third of the way down the side of the craft, roughly halfway between the cockpit and tailplane. When the plane was standing on its tail, like a helicopter, the rotors would have worked the same way. When they were flying sideways, they would work more like a big propeller. The 3 rotor blades were attached to a ring that was held up by bearings. This made it possible for them to move freely around the fuselage. Each one had a ramjet at the end. Simple rockets would have been used to get the rotors to spin. As the speed went up, there would be enough airflow for the ramjets to work, and not enough for the rockets to keep going. By changing the pitch of the blades, the speed and lift of the machine could be changed. Since the ramjets drove the tips of the rotor blades, there was no reaction torque to turn the fuselage in the opposite direction. Fuel was stored in tanks in the fuselage, and it was piped to the jets along the rotors and through the center support ring. At the back of the fuselage, there was a cruciform structure made up of 4 tailplanes with moving ailerons that would have worked as both rudders and elevators. The friction of the rotor ring would have caused the fuselage to want to turn in the same direction as the rotor. The tailplane would have given the pilot a way to control this as well as pitch, roll, and yaw. The main undercarriage was a single big springy wheel at the very end of the fuselage. At the end of each tailplane, there were 4 small wheels on struts that could be extended. This kept the plane steady on the ground and let it be moved. When the ship was in the air, the main and outrigger wheels were hidden by doors that opened like clamshells. When taking off, the rotors would be tilted like a helicopter, or more accurately, a gyrodyne to give lift. Once the plane was high enough, it could be turned so that it was flying straight. This needed a slight nose-up pitch to give some down thrust in addition to the main forward thrust. So the 4 cannons in the front of the fuselage would have been set at a slight downward angle from the plane's center line. In horizontal flight, the only real lift came from the rotors. To land, the plane had to slow down and tilt its fuselage until it was in a vertical position. The power could then be turned down, and the plane would fall until the landing gear touched the ground. At this point, the pilot would have been sitting with his back to the ground and his head facing up. This would have been a tricky and probably dangerous move. The pilot's seat was fixed in the direction of forward flight, which is different from some other tailsitter planes. The spinning rotor would also make it hard to see out the back. This was not like any other VTOL or German concept craft from the 20th century. In the 1990s, however, early plans for the rotary rocket Roten spacecraft showed a free-spinning rotor with lift providing rotors at the tips. In the 1950s, the United States made 2 prototype tailsitter planes, the Lockheed XFV and the Convair XFY Pogo. However, these planes were powered by regular turboprop engines and had contra-rotating propellers in the nose to counter torque. They also had normal wings for lift, but their cross-shaped tails with built-in landing gear were similar to the Trebfluegel in many ways. Since the Trebfluegel never left the drawing board, not much is known about what it was like in general. It was made to be a fighter plane that could take off vertically and fly on rotary wings. There is little to almost no information about how the fuselage is put together as a whole. From the drawings we have of it, we can tell that it was made up of several different parts. Behind the pilot, in the front nose section, was a section with cannons and ammunition. A rotary collar was put around the part of the fuselage that was roughly in the middle of the plane. Behind it would be where most of the fuel would be kept. At the end of the fuselage, there were 4 tail fins. This strange plane was going to be powered by 3 ramjets that could each put out about 840 kilograms of thrust. Otto Pabst developed ramjets, so these had a diameter of 68 centimeters and were less than 30 centimeters long. This plane was supposed to be powered by hydrogen gas or some other low-quality fuel. It was thought that these engines could reach a top speed of 1,000 kilometers. The main problem with the ramjets was that they couldn't be used during takeoff. Instead, an extra engine had to be used. Even though the exact type wasn't said, at least 3 kinds of engines were suggested. These included jet, rocket, and regular piston-driven engines. The pilot's seat was in the nose of the fuselage. From there, the pilot had a good view of the surroundings as a whole. The main problem with this cockpit design was that you couldn't see enough of what was behind you during a vertical landing. That's it for today, guys. Be sure to hit the subscribe button to get the latest update about the fresh and interesting content we keep on posting. See you in the next video.